Hey, hello there, and welcome back to another video and to another Advent of Code puzzle. So let's jump right in. This will be Advent of Code, and today is day 2. I have no idea what the drawing here is showing, but I guess we will find out as we go. Okay, so day 2, cube conundrum. Cube. This reminds me of last year's Advent of Code, the cube problem, which was the most difficult one. I hope that day 2 doesn't have such a difficult problem. Okay, the input already looks quite complex for parsing. Right, let's see what this is about. You're launched high into the atmosphere. The apex of your trajectory, I guess because we were launched on a trebuchet on the previous problem. The apex of your trajectory just barely reaches the surface of a large island floating in the sky. Wow, floating islands, nice. You gently land in a fluffy pile of leaves. It's quite cold, but you don't see much snow. An elf runs over to greet you. The elf explains that you arrived at Snow Island and apologizes for the lack of snow. He'll be happy to explain the situation, but it's a bit of a walk, so you have some time. They don't get many visitors up here. Would you like to play a game in the meantime? Okay. What is this game about? As you walk, the elf shows you a small bag and some cubes which are either red, green, or blue. Each time you play this game, he will hide a secret number of cubes of each color in the bag, and your goal is to figure out information about the number of cubes. Okay. To get information, once a bag has been loaded with cubes, the elf will reach into the bag, grab a handful of random cubes, show them to you, and then put them back in the bag. He'll do this a few times per game. Okay, this already sounds quite complex, at least for day 2. You play several games and record the information from each game, your puzzle input. Each game is listed with its ID number, like the 11 in game 11. Okay, so each game has a number. Followed by a semicolon separated list of subsets of cubes that were revealed from the bag. What the hell? Like 3 red, 5 green, 4 blue. For example, the record of a few games might look like this. Okay, and this is a sample input. Game 1, 3 blue, 4 red, 1 red, 2 green, 6 blue, 2 green. Okay, so on each game, it takes a random number of cubes from the bag, and the cubes, might be all of the same color or of the 3 colors or 2. And what about the order of these things? Red, blue, no, green, blue, red, and here it's red, green, blue. So the order is also non-specified. In game 1, 3 sets of cubes are revealed from the bag and then put back again. The first set is 3 blue cubes and 4 red cubes. The second, blah, blah, blah. Okay. The elf will first like to know which games would have been possible if the bag contained only 12 red cubes, 3 green cubes, and 14 blue cubes. Okay. In the example above, games 1, 2, and 5 would have been possible if the bag had loaded with that configuration. However, game 3 would have been impossible because at one point the elf showed you 20 red cubes at once. Okay, so game 3, yes, in the first time it showed 20 red. Similarly, game 4 would also have been impossible because the elf showed you 15 blue cubes at once. If you add up the IDs of the games that would have been possible, you get 8. which ones were they? 1, 2, and 5. Okay. Determine which games would have been possible if the bag has been loaded with only 12 red cubes, 13 green cubes, and 14 blue cubes. What is the sum of the IDs of those games? Okay. And we have the inputs, which is a bunch of games, I guess 100 games. Okay. And some of them have quite a few, I don't know, bags, tries, I don't remember, handfuls. How do we call these things? Sets. Yeah, okay, let's call them sets. All right, so let's jump into the code. I don't know why. Recently I was using Wayland, but for some reason OBS refused to record properly on Wayland, so I went back to Xorg. And now I feel like when I open a new thing or something, like the focus is borked or something. But anyway, let's go back to Advent of Code 2023. Open the code editor. And okay, this is something that I haven't shown you because I did it off camera, but I added some structure to the project to have different daily solutions. So I have a template here which I should be able to just copy and paste and call this thing day 2 cube conundrum. I don't know if conundrum is spelled that way. Conundrum. Okay. Almost right. Conundrum. I really like having the names of the daily puzzles in somewhere in the source code, because I like the sort of to follow the story. And I can also copy the template and call this thing simply 02. So yeah, I have a template for the source code and a template folder for the inputs. So here we can put the actual input, which would be this. The sample input, which will be this thing. And I also have a file for the sample output. This would be part 1 and part 2. For now, we only have the output for part 1, so that we can run the executable and compare it to like unknown outputs. I don't have anything like automated tests or anything like that, but this structure should make it possible to run some script of tests that, you know, runs all the samples and checks for the output in case I want to refactor things and know if things still work. So yeah, let's close everything else, and now I can run this with, let's close the sidebar and maybe increase the font size here. If I do cargo run day 2 Q conundrum, and thanks fish for auto-completing this, and I can send it because this is reading, the template already reads from stdin. We're gonna be sending day 2 sample txt. Okay, and it's just printing the length of that sample. Great. So what do we want to do? We need to do quite a bit of parsing for this, and then calculate which games. Like, the actual calculation is not so difficult, I think, at least for part 1. I guess part 2 will get more complicated. But yeah, we're going to have to parse the games, and the output, I guess each game has a set of number of red, green, and blue cubes. So maybe I think I will want to have a struct cube set, let's call it, with red, green, and blue. This could also maybe be a tuple, but no, I probably want to have names for this. And that's it. Do I want to have the games? Yeah, maybe a game does have an ID and sets, which will be a vector of cube set. Sure, why not? Let's put the most important thing on the top. And we want to say something like let games be input lines, and we are going to map these things with a function, I don't know, parse game, and we want to float upwards anything that any error that we have while parsing. Well, how do we do that? I guess we can collect this into a vector of games, and I do wonder if we can propagate things up doing this, making the parse game function also return a result like this. Okay, let's see. We have these structs. Let's define this function. Parse game, sure. It will receive a string, and it will give back a result of game or one of these things, box, din error. Maybe I can type alias this kind of results, but okay, we are here and we want to parse this game. So let's look at the input for the A2. Oh, this is quite big. Oh, actually, let's look at the sample. Sample for day 2. So to parse a game, I guess we can split by semicolon and grab the number from here. I don't know if I want to use like an actual parsing library, because I will have to learn to use a parsing library now. So yeah, I will just use splits and things like that on strings for now, but we shall see. This is already complaining. I would like to type annotation needed. Yeah, because this thing wants to know. I want to collect into a result of something. Do you now know? Yeah, a result of something. Yeah, now I can infer. Okay, I don't know if I like this, but let's roll with this for now. Okay, so how do we parse this? We can start by splitting split once by the delimiter will be the semicolon space, and I guess this split once, it gives back an option How did we convert an option to... is this what I want? No. Wasn't there an OK method on option? No. I think that is the other way around. When you have there is an expect, but I don't want to like crash. I just want to say, okay, if this is not here, return an error, like an IO error or something like that. Isn't there like a Rust convert option into results? I love it when I have like violet links in Google, because I have already made this search at some point and I have already forgotten. Okay, or this is what I wanted. Oh, but if I say okay, or and I give it a string, then it has to be like a result with string. Do I want that? Or expected gain to have a semicolon. No, this is not a semicolon, it's a colon. Okay, and this would have this thing and this. Man, this is not too pretty. Yeah, but let's keep going. So we are splitting by that, and we have ID part and sets part. Okay, and this is okay, or, and we want to propagate up. In the end, we want to say something like okay with something, let that complain. But oh, nice, it seems like a string can be converted into like dynamic error, so that is fine. That is quite nice. And actually, you know, I'm not used to doing, let's do this. Sorry, I cannot think and speak at the same time. Let's do something very stupid here. First, remember syntax, but also, okay, if we have this, this code compiles with some warnings, but if we run this with sample, it runs. We are still printing this. Let's see if this fails. For example, if this doesn't have the semicolon. Yeah, error, expect the line to have a colon. Nice. That's really cool. Actually, I want to say just the character. Yeah. That's a nice error, and it wasn't too difficult to actually propagate it up instead of using expect, which is one thing that I want to practice in this advent of code. Okay, so we have these two parts. Now, how do we get the ID from that part? Let's go back here. To get the ID, actually we can, like, it's not necessary to get the IDs, I guess, because these things are in order. So we don't actually need to parse this, I guess. We could enumerate this and yeah, but I think I would prefer to do like the right thing. So let's and ID be ID part, and again we can split once, but this time with a space, and yeah, say okay, or expected to have a space before ID, whatever. And then finally say let's ID be ID parse. No, sorry, this we have to also propagate up. Then parse, and this is also optional, and here we can have the game with the action ID. So what if we print these games? Print line and debug print of games, and for this we will need to add derive debugs. So derive debug, was this the syntax of the derive? What am I missing? Oh, like this, okay. And this complains because these things are not debug, of course. And if we run now, yes, look at that, ID 1, 2, 3, 4. Great. Parsing code is always so much fun. I hope that the sarcastic tone is understood. So now we need to parse each set. So for that, we can say, well, we have the ID. Let sets be sets part split by semicolon, right? Or I guess we have to say semicolon space, probably. And then map these things with a parse set that of course will probably fail or be optional. I don't know. I don't know if we need to be so. Yeah, maybe this thing could be optional. I don't know. Let's see. For now, let's maybe not make it optional. We're going to parse a set here. So this shall return a cube set. And of course here we can have this. Great. So how do we parse a single set? Again, this thing, oh, we have red, green, and blue. Okay. So I'm tempted to just use a loop here and make the code very stupid, something like let's RGB and start at 0, 0, 0. Or maybe just have the set. Set be a new cube set of 0, 0, 0. Right, so this is not correct syntax. Let's also derive default. and have cube set default be this thing. At the end we are going to return this set, and in the meantime we are going to do for whatever cubes in S split, and we're going to split by, what was it, comma? Let's see. Yeah, so each set, like this thing, is comma separated, which is fine. Q's string or something. Okay, in each of these we are going to do what? Well, we have to split again and say let n and color be cubes stir split once by space, and of course this can fail, and if it fails, what do we want to do? I guess we could just ignore this. I don't know. Should we ignore this? Let's not ignore this. Expected space between number and color. Okay, so this then should be a result of cube set, I guess. Okay, this should be an OK set, I guess. And instead of collecting nicely like that, can you infer this? You need annotations, right? Yeah, because yeah, I wonder why it can't infer this, because this function returns results, so it knows what this is mapping to. And then what I want to extract from here is a vector. So I'm not sure why this needs this type annotation, which makes things multi-line, and I don't like, but okay. All right, so we have this. Great. At least we are not panicking when we find unexpected stuff. So that is okay by me. Then, what are we going to do? Let's say that n is n, and we are going to parse this. So it's a number. And then we are gonna do a match on color. And if the color is red, then we are going to do set r plus equal n. If it's green, we're going to increase the green, and if it is blue, we're going to increase the blue. And otherwise, we are going to, I don't know what. This doesn't like this because it doesn't know. Wait, n is, it doesn't know what n is. So yes, please parse it into, I guess, a U32. Okay, great. Okay, does this work? Are we parsing yet? Yes, it seems like we are parsing something. 4 red, 0 green, and 3 blue. Is this correct? 4 red and 3 blue. Yeah, nice. That's great. And if we find another color, it's like, do we care? I don't know if we care, actually. We could, I guess, raise something. I say return format and say unexpected color color. What about that? Can you convert into format? You don't like that, but can't I return just a string? No. So I'm not really sure how this works. Like, what kind of how does OK or yeah, a result of okay. Wait, then return error of this. Yes, you are okay with this. But not with interesting. And I wonder. Okay, we could do something. Oops, I closed the thing. Could do something like this, although it doesn't read very nicely. I'm sure that there's probably a nicer way of doing this. Does it work if I do something like this? It does. Does this do what I want to do? So if I run now, we still have the parsing, but what if I say to violet here? We run this. Yeah, unexpected color violet. This actually worked. That's awesome. Is this something that is readable and nice? I don't know. I guess the explicit return is indeed explicit. Can I say into here, I guess? No. I'm not entirely sure of why that doesn't work and this doesn't work. Like Rust conversion things are not so trivial, at least to me. But yeah, this is cute how it reports the actual problem with the color. So let's leave it like that. Then we have the games parsed. Great. After all of this, let's compute then the part 1 answer. So we have the games. We need to count how many games were possible. So let's say the sum of IDs of those games. Yes. So we want to say games, filter the ones that are possible, then map these things to their IDs, and then sum those IDs, and all of that is going to be the answer to part 1. And we are just going to print that answer here. And how do we filter these games? Well, we can say the game red has to be less or equal than what? 13? Yes, no, 12 red cubes, 13 greens, and 14 blues. So this and red, no, sorry, game green, GG, is less than 13, and game blue is less than or equal to 14. And you don't like this because it's not an iterator. Of course, you have to iterate this. And no, you have to say if any. It's a more complex thing. So let's grab this and call this thing is possible. Yes. Or game is possible could be is possible game. Let's define this function. Is possible game is going to take a game and return a bool. Okay. What is your problem here? Oh, it takes a double reference thing. Sure. Is possible game. Nah, that's kind of ugly, but you could also use intuiter here, but it will consume the games and I probably want to reuse them for part 2, so let's keep it like this. And this is not just this, we're going to say game sets if all the sets, no, iter, and all of the sets match this condition. Let's call this variable g instead of s. This compiles, and now call this is a set, so it should be called s. Okay? Okay. What if we run this with a sample? It says 8, which is what we expected. So now let's run with the actual input. And it's 2000 and something. Let's submit this. And it is the correct answer. Great. Okay, so it wasn't that hard. The actual solution was super easy to compute. It's basically this thing, but the hard part was all the parsing. But I sort of liked how the parsing went. It is a little bit more cumbersome than using like expect and letting things crash, but it's not that much more complicated. And yeah, overall I quite like this. I'm not sure about this messy thing, but I'm okay with this. Let's add some delimiter here for the unexpected colors. Okay, whoops. Let's save and let's read what part 2 is about. Part 2. The elf says they are they have stopped producing snow because they aren't getting any water. He isn't sure why the water stopped. However, he can show you how to get to the water source to check it out for yourself. It is just up ahead. As you continue your walk, the elf poses a second question. In each game you played, what is the fewest number of cubes of each color that could have been in the bag to make the game possible? Again, consider the games for each from earlier, so the same sample. Game 1, the game could have been played with as few as 4 red, 2 green and 6 blue cubes. If any color had even one fewer cube, the game would have been impossible. Okay, and same thing for the rest. The power of a set of cubes is equal to the number of red, green and blue cubes multiplied together. The power of the minimum set of cubes in game 1 is 48, which is multiplying 4 times 2 is 8, times 6 is 48. Okay, so it's all of that. Adding up these 5 powers produces the sum, this sum. Okay. For each game, find the minimum set of cubes that must have been present. Set of cubes, What is the sum of the power of these sets? Okay. So I am tempted to, first of all, let's add all of this and commit. Add day 2 part 1 solution. And I am tempted to do something which is to maybe put these functions inside implementations of this and use like a more object-oriented thingy, because we have to compute like the minimum set for a game and also then compute the power for that minimum set. Okay, so what I want to say is let answer 2 be games. So we are computing all the power and then doing the sum. Okay, so we are also going to do a sum. I hope that U32 is okay. We're going to iterate over each game again, and we are going to map each of the games to the minimum set that could have produced that game, and then for that set we are going to ask for its power. And then we are going to sum all of those things. And that's it. That is the answer for part 2. Okay. So of course this thing doesn't exist. Can you generate? Yes. Minimum set. Look at that. I really like the Rust analyzer like capabilities of generating things and doing refactors and like it. I think it in the short amount of time that I have been programming in Rust, it has improved quite a bit, and I really enjoy that. It's just a quality of life things that I like. So okay, this minimum set should return a cube set. And how do we do that? What is the minimum set? So I guess we can iterate over all the sets and just keep the minimum of no, sorry, it should be like the maximum, right, of those red, green, and blues. So we can say, okay, similar to which one was it? The loop that we were doing here when we were parsing, and we can also like put these parse functions inside of this impulse. We're going to do that later, but here we could say let min set, I'll just call it result, is going to be cube set default. So let's start with 0. And then we're going to say for each set in self sets, do what? Well, the result red is going to be the result red and the maximum of that and the set red. Okay, does that make sense? It compiles at least. Then we are going to do the same with, well, with red, green, 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 and then blue, blue, and blue. I guess we could print these minimum sets. Yeah, let's do that. So say sets vec of things and just map to the minimum set. Okay. And collect this and then just print line sets. These are the minimum sets for each games. We print back this. Let's comment this part. Well, I run it with the actual input. Let's run it with a sample. So the minimum set for game 1 is 4, 2, and 6, which I think is correct. 4 red, 2 green, and 6 blue. So this seems to be fine. Let's go back to what we were doing before. And the power. Please generate a power method. And power was just multiplying things, right? The power of a set of cubes is equal to the numbers of red, green, and blue multiplied together. Great. So this is U32 and self red times self green times self blue. I have to admit I'm sort of a sucker for this kind of extractions into little methods and things. So okay, we have all of that. Can we have then the answer for the sample? 2286. Is this correct? Yes, this is correct for the sample. And I don't know if the input will overflow with a U32. No, it's well below that. Okay, is this the correct answer for part 2? And it is. Nice. Okay. So, yeah, part 2 was not that difficult either. Let's add these changes. And let's also make it consistent. At least this is possible for a game. Let's move it inside the game info. So a game is possible just say self if their sets are all well, and I guess I could here delegate to the set and say if all the sets are possible themselves, but this is all right. yeah, also this could be delegated to each set, but it's okay. I don't want to go like super purist, object-oriented purism. So here we should be asking if the game is possible. And now the formatter likes this to be a one line. Okay, so now we have the input and parsing here. We have the two answers and we are printing those two things. Great. And if we run this now with the inputs, we have the two answers from before. If we run with the sample, I want to copy this output to the sample out for day 2, which is the expected output. So now that we have this kind of expected outputs, we can do like this and diff it. This would be diff of the input and input. Can I have a new line here, fish? Yes. Pass it to diff and diff the input with inputs 0 to sample out. And if we do the diff, there is no diff. And of course, here, if we have a different thing and we run the same thing, it will say we know that we made a mistake on our implementations. So this will, I guess, in the future, we can test manually by doing this diff, or we can then automate it in the future and run all of the samples against all of the expected outputs. But for now, this is okay. So answer 1 is we filter the games that are possible and then map to their IDs and sum all of those. And in part 2, we map to their minimum sets and ask each set for its power. So yeah, this looks fine. I guess one last thing, I maybe would like to put this parse game in here. So this is just parse, and well, the result is all the same. So the code is just the same, but we call it game parse. Okay. And when parsing the games, we are also parsing the sets, so we can say set parse. And can you, no, cube set parse. No, the thing is not as intelligent as to generate that thing, but we can put it here, I guess. It's this thing, move it up, and call it parse. Okay, now everything still compiles. Let's run the input. It is the same thing. Let's see the drawing here. So I guess supposedly this is the floating island that we have. Oh yes, this is this is a drawing of the trebuchet. Nice. And I guess we landed on the floating island and we are now going to be traveling along that island. That's great. Are my answers still what I expect? Yeah. Okay, so I think this looks all right as the final code for this solution. We don't need the debug things, but this is okay. We are parsing stuff, and we are delegating things like it is possible, minimum set, and things like that. I quite like it. And the main code is overall quite readable, albeit these explicit results things that we have when collecting. I have to see if there is a better way of doing this, because I cannot put this in here, I think, because the games are not of that type, and I want to like short circuit this these results to propagate errors up. But yeah, this looks nice. So let's add all of this and commit and say add day 2 part 2 solution. And I think that's it for today's puzzle. So if you have been, thanks for watching and see you later. Bye bye. And